Welcome to this week's episode of Humans in 5.
We've dedicated the odd episode here and there to touch on topics to do with human nutrition. Many of us worry about our diets and have a curiosity about the origins of the foods that have helped to make us human.
Researchers looking into our evolutionary past often face many challenges when aiming to determine the types of foods our ancestors would have eaten. Many research have suggested that particular food types may have driven not just our diets, but key events in our evolutionary history.
In particular, the consumption of meat has often been used to explore and explain many traits of interest to human evolutionary researchers. Some have hypothesized that our ancestors began hunting and eating small animals, quite like some of our contemporary primate cousins, deep in our evolutionary past.
It's been suggested that meat consumption may have further developed with the manufacture of flake stone tools, which are very fine and tricky tools to make. As such, meat eating was associated with higher cognition and the ability to plan and make these particular tools.
A group of researchers have pointed out a key issue within this framework. A recent paper by a team from Yale, Oxford, Arizona State University, and the University of Chicago have noted that these cognitive developments depend on a larger and more complex brain. In order to maintain that larger, more complex brain, we need a little less meat and more fat to keep that organ going.
Our brains use up huge amounts of energy as they're made of quite expensive tissue, and that helps keep our minds going. Lean meat tissue that's found on many small animals would not have had the fat or caloric content to keep these pricey brains going in the long run.
So, our brains needed access to expensive, calorie-rich, high-fat foods to keep on ticking. The question is, in the past, what kind of foods could meet those needs? Jessica Thompson, the lead author of this study, suggests that bone marrow could be the special material that meets all of those criteria.
As early as 4 million years ago, our human ancestors may have accessed bone marrow from the bones of large mammals. Early human relatives lived in open grassland environments. Our ancestors likely didn't take down large mammals, but they may have scavenged marrow from large mammals killed by other predators. They may have used large rocks to smash open these bones and get at that juicy marrow inside.
Bone marrow may have met the high-fat, high-calorie threshold required to support our large and expensive brains. It may also have helped keep us healthy, as bones often protect marrow from developing any bacterial growth. By helping our brains meet their potential early on in our evolutionary family tree, bone marrow may actually have helped shape our brains into the remarkable tool-shaping, problem-solving organs that facilitated further evolutionary developments, as well as our current brain-oriented lives.
We hope that you think about fat a little differently, though as with all things in our modern lives, we now only need it in moderation.
Thanks for watching, and we'll see you next time on Humans in 5.
And don't forget to subscribe.